Greetings, geometry students. Today we're going to be getting into something that is quite different from anything that you have ever seen. In fact, this is as close to new math as we are going to get to anything all year long in geometry. The title for today is Trigonometric Ratios, and let's get started. Our objective for this day will be the student will learn the primary trigonometric ratios and how they operate within right triangles. I have no idea at this point what date this will be. I'm recording this lesson pretty far in advance, so just leave the date blank and we'll fill it in when it gets a little closer. As always, press pause anytime you need more time to copy things down and hit play when you're ready to move on. Okay, now here's a bunch of information. You do not need to copy this screen down. This is a lot of stuff that we have discussed over recent weeks. So we've been studying right triangles a lot. We have seen that there is a relationship amongst the angles, that three angles in a triangle add together to be supplementary. We have seen there's a relationship amongst the side lengths in right triangles, where the two legs squared and added together equals the hypotenuse squared. We have seen the special right triangles with their own rules, where like in a 45, 45, 90 on the left, the hypotenuse equals the leg times the square root of 2, or in a 30, 60, 90 over on the right, where the hypotenuse is always twice as big as the short leg, and the long leg is always whatever the short leg is times the square root of 3. Now, all of these rules have been kind of driving towards one centralized topic. And that topic is that in a right triangle, just about everything is related to everything else. And there are some mathematical operations that kind of tie the bow around this package and pull it all together. Okay, so we're going to start taking a look at this for the next 3 days or so, and we're going to get the basics today. Okay. Now, take notes here. Before you can begin a discussion about trigonometry, we're going to need some new vocabulary to go along with it. But a key to everything is that trigonometry, these ratios that we're getting ready to get into, they only work in right triangles. Now, that's going to be critical. If you try to use trigonometry in what we call an oblique triangle, meaning it is not a right triangle, an acute triangle or an obtuse triangle, those are oblique. If you try to use it in an oblique triangle, then that is going to cause you to get some incorrect answers. Okay, so the basic rule, no right triangle, no trig. Okay, now the trig functions focus on one of the acute angles in a right triangle. Now, of course, we've said all along that all triangles have two acute angles, and of course, we're insisting that the third angle be a right angle. Okay, so the right angle is not the angle that we will focus on. Okay, we have to make sure that the right angle is actually in the triangle, but we will be working from one of the two acute angles. Now, the acute angles in trigonometry vocabulary, they are referred to as theta. Okay, and theta is that little symbol that you see on the right there. Looks like a 0 with a horizontal line through it. Theta is part of the Greek alphabet, and I told you earlier this year you're going to start to see more and more letters from the Greek alphabet appearing in our mathematics, and this is just another example. Now, okay, we're putting theta as one of the two acute angles in a triangle. So basically, I've just drawn the same triangle twice here, okay, and put theta in either location. Now, theta, as we said, is acute, so it means it's always going to measure between 0 and 90 degrees. It will never, ever measure 90 degrees or higher. Now, either of the two acute angles are allowed to be the theta. Okay, it will not affect the trigonometry. You can switch locations from one acute angle to another acute angle anytime you see fit and set up the problems from there. The thing you're going to have to keep in mind is that the side lengths, the names that we're getting ready to see, are labeled according to where theta is positioned. We'll start off with the obvious and the easy one, and that is the hypotenuse. The hypotenuse continues to be across from the right angle. So no big deal on that one. We should know exactly where the hypotenuse is. Okay. Now the other two side lengths are a little bit more difficult to position, and let's take a look at those. Okay. There is the next side that I look for in a right triangle where trig is concerned is what's called the opposite side. The opposite side is the side that is across from theta. Now I've drawn you two different triangles in this particular case, basically to prove one point, and that is your opposite can be in two different locations. It depends upon where theta is positioned. So if you happen to choose the lower right hand angle, like the one on the right, or I'm sorry, the one on the left, for theta, that puts opposite side over on the left. In the right-hand diagram, if you happen to be working with the top angle as theta, then that's going to put opposite down at the bottom. Point is, the opposite side will move as theta is moved. The third and remaining side of the triangle, this is the one I leave until last because people do have a tendency to mess this one up when they're looking for it in the triangle. The remaining side, which is also next to theta, is called the adjacent side. Okay. And just like with the opposite side, the adjacent side will show up in different places depending on where your theta is at. Okay. Now the reason I saved the adjacent side for last for you guys is really very simple. Well, the word adjacent means next to. Well, unfortunately, there are two sides that are next to theta. One of them is the hypotenuse, and the other one is the adjacent side. So if we find the hypotenuse first, which is what most people tend to do anyway, if we find that one first, then that kind of eliminates the possibility that we might get that one confused with the adjacent side. Okay. So those are the three side lengths and positions of your right triangles when trigonometry is concerned. Okay. Now, when used in conjunction with one another, we're going to see a very strong, solid relationship between angle measurements and side lengths. Now, we've already flirted with a little bit of a relationship. We know that the largest sides and the largest angles are across from each other in the triangle. Smallest sides and smallest angles are across from each other in the triangle. We know that, but what we're talking about now is we're actually going to be able to calculate side lengths based upon angle measurements. And we're going to calculate angle measurements based upon side lengths. So these rules are going to be a little bit different for us. Okay. Now, in order to remember the mathematics of the trig functions, there is one word, if you want to call it a word, that you need to be able to remember, and that word is SOHCAHTOA. Okay, SOHCAHTOA. Get this guy copied down. Pay special attention to the spelling. If you misspell SOHCAHTOA, it's going to cause you all kinds of problems because this guy, this 9-letter word, is an acronym, which means every letter means something. It's every letter is the first letter of a word, and if you get these guys out of order, it's going to cause you to set up some math wrong. So SOHCAHTOA, SOHCAHTOA. Okay, now let me show you what SOHCAHTOA means and how to read it. Okay, SOHCAHTOA is actually three groups of three letters. SOH is one group, CAH is a second group, and TOA is a third group. Okay, so write that down again, this time putting little dividers in there, just like I've done. And then here's what happens from there. Okay, we're going to break them down into their three groups, SOH, CAH, and TOA. Now, I already said that the spelling of SOHCAHTOA is important, and that is because the different letters mean different things. Now, the first letter in each group, the S and the C and the T, stand for the three different trigonometric functions, which are sine, cosine, and tangent. Okay, sine, cosine, and tangent. Now, if you're wondering where the OH and the AH and the OA come from, well, some of you have probably already figured it out. O is for opposite side, H is for hypotenuse, and A is for adjacent side. Okay. The second letter that is on the each group of three is actually referring to a numerator of a ratio. So in the case of sine over on the left, the numerator of a ratio that we're going to have is going to be opposite. Okay, for cosine, the numerator is going to be adjacent, and for tangent, the numerator is going to be opposite. The third remaining letter for each of the three groups is the denominator of the ratio. So sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, these are actually three mathematical rules that we are going to be working with for the next 3 days. Okay. Now, in a kind of shortened and abbreviated format, here is basically what we're looking at. Now, please notice that theta has made an appearance in these rules as well. Actually, the trig functions, sine, cosine, and theta, by themselves, sine, cosine, and tangent, they do not mean anything without the angle measurement to go with them. Sine and cosine and tangent need to know what angle you're actually looking from. So that's where theta comes in. So as you see on there, the rule says sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. Tangent of theta equals opposite over adjacent. So there's actually three pieces of unknown information that are going to have to be plugged into these ratios when we work with them. We'll have to tell the trig function what is our angle measurement theta. We'll have to tell the ratio what is our numerator, whichever side that may be. And we'll have to tell the ratio what is our denominator, whichever side that may be. Okay. So these are the three what are called primary trigonometric functions that we will be working with in these lessons. Okay. There are actually three other trig functions that are called secondary functions, but we will not get into those in geometry. That is more of a pre-calculus topic. All right, so let's see if we can figure out how these ratios are going to work. Okay, so let's start off just getting familiar with the various side names and using the different functions. So identify the following ratios. We have a right triangle, triangle ABC sitting in there, and we have all kinds of side lengths going on in triangle ABC. And then we are asked about three particular ratios. We are asked about sine from angle A, or the angle near vertex A. We are asked for tangent of the angle near vertex C, and we're asked for cosine of the angle near vertex A. Okay, well, keep in mind, we're just identifying the ratios. So all we really need to ask ourselves to answer these questions is what is sine from the vertex near angle A? Well, what does the ratio sine even mean? Okay, well, think back to SOHCAHTOA. Okay, where is sine positioned? SOHCAHTOA, it is the first of the three groups, SOH. SOH. S stands for sine, O stands for opposite, and H stands for hypotenuse. Okay, so let's see if we can figure this out. From vertex A, which is up here, I'm doing this on my laptop, so forgive me if my penmanship is bad. There's our theta in this case, the angle near vertex A. Okay, sine says opposite, which is across the triangle from theta. Okay, that would be a 4. Okay. and it says the opposite should be over the hypotenuse, and the hypotenuse is always across from the right angle, so our ratio is 4/5. That's it. The ratio of the sine function from vertex A is 4/5. The next problem we are asked to look at is tangent from the angle near vertex C. Okay, so let's have a look at that. Tangent. What is the ratio that goes along with tangent? Well, think about your word, SOHCAHTOA. SOHCAHTOA. TOA, the very end. T-O-A. So tangent is represented by opposite over adjacent. Okay, but this time we are told to look from the angle near vertex C. Okay, so our theta is going to be down here this time, and opposite would be a terrible line, but I managed to actually get to the side eventually. Okay, would be the 3. Sorry for the ugly 3. Okay, there's your opposite, and which of the sides is adjacent? Now remember, adjacent means next to your theta angle, but of course we do not want the hypotenuse. That would be hypotenuse. The other side that is next to angle, or the vertex C, would be the 4. So tangent from angle C, or vertex C, would be 3/4, opposite over adjacent. Okay. And lastly, we are asked to look at cosine from the angle near vertex A. So once again, we are up here for theta. Okay, and what is it that cosine means? Well, think about your SOHCAHTOA. Okay, SOHCAHTOA. Cosine is the middle group of 3 letters. That's the C-A-H. Okay, C-A-H. So cosine is adjacent over hypotenuse. Well, from vertex A, adjacent would be the 3. Okay, so another ugly 3 there for you. And that should be over hypotenuse. Hypotenuse is across from the right angle, so that would be your 5. Okay. There's no other math to go along with this. Actually, we'll get to some more math, but for right now, all we were asked to do is identify the ratios. That is SOHCAHTOA, S-O-H-C-A-H-T-O-A. So those are the 3 ratios that would accompany those 3 questions. Okay. Got another diagram here for you, and I have 5 ratios that you are asked to identify. So please copy down your triangle and see if you can figure out what is the ratio to go along with sine x. What is the ratio for cosine y? What about tangent y, tangent x, sine y? See if you can figure out these 5 ratios and bring them with you to class on the day that these notes are due. And we'll go over them together as well, and we'll see if you got them right. Appreciate you finding time to tune in and get your notes. I will see you in class.